Thank you, everyone. I think it's an honor to be here. Special thanks to IGBC for sort of organizing this kind of an event. And my conversation today, I think I'd like to make this interactive too at some point, is to talk a little bit about India and the energy transition. Of course, the larger part of the focus is going to be on buildings, but I think what I've tried to do is essentially showcase a roadmap towards net zero, and that's going to be the larger focus of what I'm going to be talking about. But I thought I would start by just sort of painting a picture of where India stands at today. And that's a tale of two extremes. What those extremes look like in the last 12 years, and this is actually something that I remember because 12 years back I moved to the United States to do my master's. And at that point, we had 300 million people without any access to electricity. And over the course of this last decade or so, we've electrified 300 million people. In that sort of journey, I think companies like Wally and several others have come into the mix. And solar, just to take one example, has grown by 100x in the same 12 years. That's the kind of growth that we've seen in solar in India. And finally, why has it grown so quickly and in such a scale is also because today, energy generation through solar is the cheapest form of any generation anywhere in the world. That's the kind of difference that we've made with solar in this country today. And that's why it's going to scale and sort of continue the path that we're all seeing as we sort of go forward. But at the same time, we're the third largest emitter of greenhouse gas emissions already. But then there's sort of a different story that comes to light when we look at the per capita numbers. And that shows India stands at 103rd in the country ranking list when it comes to per capita emissions. Now, why that makes a difference is because as we're sort of going forward, our consumption is going to increase and increase and increase. In fact, just for numbers, I've put some perspective. Today, an average Indian consumes 1/10 of the average American. And so as we continue sort of growing and developing, that consumption is only going to grow. And with the expanding economy, population, and industrialization, India is estimated to see the largest increase in additional energy demand among any other country until the year 2040. That's the sheer demand that we're going to see over the coming 2 decades. The task ahead is very clear. India must get to net zero, but while growing our GDP. I think that is the task that all of us here have, industry, academia, government, to decouple GHG emissions from GDP growth. If you look at every developed economy and notice their sort of growth, what you will see is GHG emissions has been growing the same way GDP has been growing. We have this unique task and challenge, I think we're up for it, to decouple the two. And that's sort of what we've been trying to address at IIT Madras Research Park. And this is in some sense the technology roadmap that we've set forth. There are 3 different pieces on energy generation, storage, and consumption. And across these 3 things, and we've sort of laid out what are the technologies that we think will be playing an integral role in essentially helping us get to that energy transition that we're all looking at. I'm not going to delve into the details of it here, but I'll be talking about a lot more about it over the coming slides. But across the board, there are 3 additional things that I think we should be paying attention to. The first thing being energy efficiency. Everything that we do in terms of generation, storage, as well as consumption needs to be at the most efficient possible manner as we can. And the second thing is the grid is evolving and changing. And so management of this generation, storage, consumption becomes increasingly important. And finally, I think while we do all of this, there's an important piece of recycling and circular economy that I think all of us must sort of also consider that we should sort of take into the mix while we're sort of growing and developing. But where do we start? And that's sort of the question that we ask ourselves. 75% of India's electricity today is consumed by three sectors: industrial, commercial, and housing. And when we looked at the numbers, the cost of electricity for the commercial category is actually the highest amongst all other categories. And this is the case in all states across the country. On average, it's 40% higher, the commercial tariff, compared to other categories. And just for numbers, India is actually estimated to add an approximate 700 to 900 million square meters of urban space every year for the next decade. Now, I want to put that in a different perspective or light. If you have ever looked at the city of Chicago on the map or visited, India is going to add a Chicago-like city every single year for the next decade and a half. That's the sheer volume of growth and construction that we'll be seeing over the coming years. And what we're saying is, if we can build these infrastructure in the most sustainable, energy efficient, and renewable manner, then that's what's going to be needed as we sort of go forward. I think what we've highlighted in all of the work that we've done is try to make all of the technology commercially viable or competitive in the market such that they can be giving a return on the investment for any of the investors that are setting up these pieces. I'll jump straight into what we've been doing at the research park. For numbers, we're a 1.2 million square feet commercial complex-like setup spread across roughly 11.7 acres. Our average daily energy consumption is about 70 megawatt hour or 70,000 units per day. The contracted demand is about 5,800 kVA. The total cost of electricity per unit, including variable and the fixed demand charges, is about 12 rupee 31 paise in Tamil Nadu right now as we speak. And what we sort of decided to do was, when we started all of our work, we said we're going to base that on just understanding the building, consumption, and why we're consuming so much. And so to that effect, let's just pick up my pointer here. We've installed roughly 1.2 million data points every day just to understand how, where, and why we're consuming so much energy. Because that's where one can sort of address the gaps that we have before we go about solving for it with technology. And as the gentleman in the previous presentation also mentioned, I think that the greenest form of energy is actually the one we don't use. And so what we've started with is actually to try and reduce our consumption. Here's an example of what we've done. In our campus, 40% of my electricity bill just goes in air conditioning. That's the case in most commercial buildings. And this is a geospatial analysis that we've done of the research park facility. And one of the things that we found, very interestingly, was that the west facade, this piece or this building that I'm pointing towards with my cursor here, is actually getting heated 30% more than all of the other blocks. Now what that means is that for the same building, same space, same occupancy, just because he is west facing, he has a 30% higher cooling bill. And so if we can sort of address these things during design and construction, then that's the best option. But what we've done, since the building was already built, was sort of work with companies like Saint-Gobain and several others to essentially build out material and glass that is cutting away the heat that is entering the space. Now what the benefits of that is, I have a capex reduction, that much lesser air conditioners to put up, and then an ongoing opex reduction, the electricity bills that I need to spend much lesser on. And that's sort of the approach that we've taken in terms of reducing before we go about solving with other technologies. Again, the because cooling is such a big component of our electricity bill, we've sort of gone about just deep diving, and there's an entire team that just delves into the data aspect of how chillers and cooling systems work. In fact, we've computed and crunched over 1 billion data points to try and find efficiency gains in all of the things that we're doing in terms of running these cooling systems. I'll show you one relevant technology that we've implemented. I'm not sure how much of it is visible here, but as you can see, this is a variable sort of valve that's moving on our air conditioning systems. Now imagine a room like this. Whether there's 100 people sitting here or there's 5 people sitting here, the same amount of cooling is going into that space. And so what we did was essentially installed occupancy as well as temperature monitors and split a large room like this into sort of 8 smaller zones. So depending on how many people are sitting in that table and what is the temperature over that, we're providing only that much cooling. And in our results, we're finding that that's already saving close to 30 to 35% in operational costs of energy usage. That's the kind of sort of innovation that I think is essential and required for us to address some of these challenges. In terms of energy generation, I think this is the piece that most people already understand, but I'll quickly run through it. Solar rooftops only provide as much energy of 5 to 10%. So what we've done is gone the open access route. We've installed 5 megawatt of solar and about 2 megawatt of wind. That's almost powering 100% of the campus's requirements. But there's one factor that I think most people overlook, but few people are already starting to now, is on the storage piece. Solar and wind is available only when the sun shines and the wind blows, and the demand for electricity is of course through the day. Now, banking regulations have changed, as our gentlemen should know here. From 12 months it was, about 5 years back, it's moved to 1 month, and now very closely we'll be talking about moving into minutes. Essentially, there's going to be an intermittency problem. Demand and supply of energy is always going to have a mismatch. The only way to solve for that is through energy storage. And that's sort of the piece that we're trying to solve for the next. 40% of my consumption, as I mentioned, is just cooling. And so what we did first is install a thermal storage system. This, the picture here on the right, is a 300,000 thermal storage tank that we've installed, roughly about 2.5 megawatt hour. All it does is, whenever there's excess solar, we take that excess energy, run our chillers, chill the water to 6 degrees Celsius, and store it in this tank. It's insulated and retains that temperature. And whenever there's no solar or wind, we take this chilled water and utilize that for all of our air conditioning requirements. Works very well, essentially because we're using it in the end form that we're storing it in. Cooling requires chilled water, use it in that form. The second type of storage, and we've actually been the first one in the country to develop the indigenized battery storage system. This is a megawatt hour pack that we deployed at our campus 2.5 years back. The first of its kind in the country that was inaugurated by the Minister of Finance, is essentially providing us all of the remaining storage requirements of the facility. I'm not going to talk about long duration storage because I think that's a different problem, but one of the things that we need to understand is because of the seasonality of wind, we need different types of storage systems to address that problem. In fact, today, if you look at India's wind generation, 60% of it is happening across 4 months. There's a large seasonality problem that we're trying to address there. Finally, I think the energy management piece, and this is, I think, what's going to be critical as we sort of go forward. Gentlemen here also spoke about demand flexibility and how and why it's so important. We have different sources of energy generation, solar and wind, different types of storage, and a multitude of consumption heads. We've developed an intelligent energy AI-powered system that is managing this real-time 24/7 and also helping us save on costs. Now the first use case of that is time of day pricing. Essentially, between 6 to 10 a.m. and p.m., the cost of electricity is 25% higher. It's the time of day pricing that is implemented. I think that's also the case in Maharashtra here. And what we do is we charge our batteries and storage systems during the off-peak hours and utilize it for a direct 25% savings. The second benefit is one about the fixed charges. This is actually the piece that many people don't really see. In our case, we have a contracted demand of 5,800 kVA and the per kVA rate is 608. That means irrespective of how much I consume in a month, I am paying 35 lakh rupees fixed. Now we looked at why that is so and if that is required. And what we found is actually this is our average 24-hour consumption profile. If you notice here, we're reaching that 5,000, 5,800 mark only for a few minutes to an hour in a day. Essentially, we're underutilizing that contracted demand. And so what we did was essentially start by drawing a green line at the 4,000 mark, and we said anytime it goes above that green line, I'm going to use my storage systems. And then we said, okay, let's do this even better. Reduce it down to the yellow line. Anytime it goes above that, utilize our storage systems. Effectively, that alone is saving us about 5 to 10 lakh rupees every month. And that's essentially what we're saying. Bring in these value-added components with the sort of flexibility that is required by the DISCOM, because the DISCOM is also facing challenges around peak surges. So this is also sort of helping manage flexibility and the demand at the DISCOM level and at the consumer end for us and save costs in the process. Finally, to close the loop, I think this is a problem that we've taken up because we believe R&D is important in these spaces, is there's a hot and cold problem. If you notice in your home air conditioner, as you're cooling the room, the outdoor unit is throwing away hot air. What we did is we've captured that hot air and sort of heating water and sending it to our cafeterias and hotels. Essentially free waste heat recovery. And finally, there's an end-of-life problem, because I think as a conscious, environmentally aligned citizen, we're also inclined to sort of look at the environmental aspects of storage. And we've set up a battery recycling lab where today we're able to recover 95% of the materials at a 98% purity level. That means all the materials that we're using, we're going to reuse at the end of its life. Finally, and this is all about the numbers, the green print, we've essentially brought down our cost of electricity and saving 33 lakh rupees every month based on all the interventions that we've sort of demonstrated here today. The final impact of this is about 30 to 35% reduction in electricity costs. Last year alone, we saved about 4.3 crores in terms of INR rupees. And in the process, of course, this is why we're all here, cut down emissions by about 11,713 tons of CO2. The approach is scalable across the country. There's about 1 billion square feet yet to be built, and increasingly more that can be sort of adopted with these kind of technology interventions. And we're saying we're ready. The costs are declining and getting even better as we sort of go about thinking about implementing these kind of solutions into the mix. Finally, we also sort of said, can we now take this solution into the market? And so IIT Madras has incubated over 550 companies, the likes of Aether, Agnikul, Unifor, all that have revolutionized these kind of innovations. So to take this entire model approach out, we've incubated a company, it's called Elements Energy. And here we're also thinking about not just buildings, but also sort of the entire grid in its sort of entirety. And so one of the projects that I'll sort of finally conclude with that we're working on is with the Andhra Pradesh DISCOM. Effectively, we're doing energy management by leveraging AI and ML solutions for optimization. And it's essentially a demand response program where we're connecting to all the smart meters and real time providing flexibility for the DISCOM and for the user to help both ends save on costs, carbon, and the much needed flexibility that we're all sort of talking about. And this is enabling essentially peak energy demand reduction, costs, and carbon for both the DISCOM and the consumer. And with that I'll close, but the essential goal that we're trying to do is accelerate the green energy transition. We're sort of saying, should we be looking at celebrating about 100 years or a century of our independence by really going green? I know it's a very ambitious target, but if we can all sort of really get together and rally around the troops, we're saying it is really possible. And with that, I'll stop and thank you very much. And would hopefully like to take up any questions and thoughts if you have any. Thank you so much.